Hi and welcome to the channel. Today we will build another SFF PC using the SSUPD Meshroom S. As you can see, this has mesh side panels on almost all sides, and it's a good mesh as you can almost see through the parts inside. As a background, this is a very interesting case for me as this can fit an ATX motherboard. It is also not a traditional sandwich style orientation where the GPU is not oriented horizontally but vertically instead. This has some similarities to the mATX V2 which I reviewed previously. In terms of volume, they are both 15 liters though the mATX V2 is longer and taller but slimmer than the Meshroom S. Both can fit up to ATX motherboards. The CPU cooler limit height is similar at 74mm for the Meshroom and 79mm for the mATX V2. Meshroom S can cater for AIO regardless of configuration, while the mATX cannot. Meshroom S can also cater for dual AIOs, meaning an AIO for the CPU and another AIO for the GPU. As for the GPU, both can support up to 4 slots, but the length limit is longer with mATX. You can still lengthen the GPU limit for the Meshroom S, but you need to pay extra for that. For PSU, both can support ATX PSUs with their own different limitation factors. And I just need to highlight that the GPU port access for the Meshroom S is at the bottom rather than traditionally at the back. It also has a very complicated compatibility matrix due to its flexible design and expandability. So with that, to simplify things, I'm introducing the Meshroom S compatibility Venn diagram. So you can choose two major components but not all three at the same time. Example, you can choose an ATX motherboard and a fat GPU, but you can't have an AIO. You can somehow make it all compatible by buying a fan extension bracket, but that will also extend the size of the case. It is quite an expensive add-on and we don't have that locally, so I didn't test it. As for the case itself, it is utilizing push-pin side panels, and so to open you just need to pull the side panels. As for the accessories, it is contained in a tight brown box. Inside the box is a multifunction bracket, spare PCIe cover slot, spacer, a 90-degree angle HDMI cable, HDD/fit screw spare, SSD screws, standoffs, PCIe riser bracket, motherboard and GPU screws. It also has a nut to remove the standoffs, zip ties, spare clips for push pins, manual though this is available online. As for the front panel, it has USB-C and USB 3, and the power switch at the back. There are side fan brackets which you have to remove first. If you bought the case and riser bundle, then the PCIe riser is already pre-installed in the middle position, which will cater for 332mm GPUs. For this build, I'll be utilizing an mATX motherboard where the radiators will be facing the side of the case at the rear, while the GPU will be at the front. I have other videos, but that will make this video too long and too repetitive, so I'll publish those separately in the future. In this build for mATX, I'm using the Asus TUF B550M Zaku paired with a Ryzen 7 5800X and a G.SKill Ripjaws V 16GB 3200MHz CL16 RAM. I also have a different footage of this with ATX motherboard, but the build process is exactly the same. I actually don't need to test the installation of an mATX build, but this is the only AM4 motherboard that I have that I could use for some comparative results against the ITX counterparts. Before you tackle the case, ensure that you have prepared the motherboard, install the RAM, CPU, and VMe SSD, install the necessary mounts for the CPU cooler as well. For this type of installation, remove the PCIe brackets at the top, remove the middle USB. To remove that, you have to remove the whole front I/O, and then you'd be able to remove the screw for the middle USB port. Screw back the front I/O, screw the PCIe card bracket, remove the PCIe riser standoffs, and riser if it is still there. As for the PCIe riser standoffs, I just placed it in position 1, which is aligned to the rear GPU position 2 build. Screw the 270mm PCIe straight riser. Move the GPU bracket to the front, and I just aligned the GPU bracket from its old position. I then installed the other PCIe card bracket by putting in one 5mm and two 10mm standoffs. This is actually wrong as it will hinder the installation of the PSU later. As for the GPU, I'll be using the Gigabyte RTX 3060 Gaming OC. Install the GPU and screw the baffle. I then fold the PCIe riser as instructed in the manual. Ensure that you have installed the motherboard standoff at this point. Install the I/O shield and then install the motherboard. Plug the riser to the motherboard. As for the PSU, I'll be using the FSP Dagger Pro 850W gold power supply. So while installing the PSU, I then noticed that the PCIe card bracket that I installed earlier hinders the PSU installation. I realigned the pesky bracket and then installed the PSU. For that bracket, you need to put the standoffs on the second hole rather than the hole at the edge. Also, it will be installed diagonally rather than straight. I then plug the 24-pin power cable, CPU power connector, PCIe power connector. I then remove the top side brackets which had 8 screws on each side. I also removed the spacer to be able to remove the other side bracket. You can now install the pump to the motherboard and CPU. At this point, I tried to fit in the radiator but the GPU is hindering it. With that, I unplugged the GPU first, just slightly to give space. Install the radiator and then plug back the GPU. I then installed the top bracket. I made two mistakes here though. First is that I should have pushed the radiator down even further. I also forgot to install the side fan bracket, so I installed it late. I then plugged the USB 3 cables, power switch, pump, and fan. I then lastly installed the top bracket at the motherboard side and the spacer. This is actually wrong as I should have installed the spacer first before the GPU side top bracket. As for for the pump cover, the ARGB header was actually covered by the PSU, and so I'll not be able to install that for the mATX. And since there are no fans that will be hit by cables, feel free not to do any cable management and just close the side panels. As for the troubles in my builds, I was entering a boot loop with the B550M Zaku with RTX 3070. It will actually try to go to Windows and then restart. This happened after I installed the driver. I tried to set the GPU link to Gen 3 instead, and it went to Windows successfully. This means that either the riser is actually just Gen 3 or I destroyed the riser by stretching it and accidentally downgraded it to Gen 3. I think it is the latter though. I actually encountered more issues but not related to Meshroom S, which will be detailed in the next build video. As for the temps, I tested it in ITX in both RTX 3060 and 3070 in both AIO and air cooling with 2 case fans in exhaust and intake modes. I also tested the mATX and ATX in both GPUs, but as they're limited by configuration, only the RTX 3060 is paired with the AIO and the 3070 is paired with air cooling. I also tested the ATX RTX 3060 AIO pairing with the LGA 1700 standoff, which will be explained shortly. And lastly, the DeepCool LT520 in an open test bench as a baseline. As for the CPU temps in ITX while running Cinebench R23 for 30 minutes, the open case AIO averaged at 80.72 degrees Celsius, while inside the case, the AIOs averaged at 83 to 85 degrees Celsius. The air cooler simply maxed out at 90 degrees Celsius. As for comparison, the NR200P is slightly worse by 1 degree Celsius on average, but do note that it is using a different cooler, and even at AIO, it has 2 exhaust fans at the top. In Lianli A4H2, it was just underwhelming at this point, having the same temps as the air coolers. As for the temps while benchmarking FF15 for 30 minutes, the open test bench is just 2 to 4 degrees Celsius cooler than inside the case, which makes the Meshroom really competitive at this point. As for air cooling, notice that the exhaust config is slightly better by 2 to 4 degrees Celsius as compared to their intake counterparts. As compared with the open test bench of ZZ240, the LT520 isn't much different in average temperature, but somehow the ZZ240 had a significantly higher max temp. The NR200P performed by 1 degree Celsius worse than the worst 3070 Meshroom configuration, which is the air intake mode. And the Lianli A4H2 is now at the bottom of the charts in both air and water cooling. As for the GPU temps, it is pretty much tied for the RTX 3060 with around 1 degree Celsius difference on average. As for the 3070, for some really unknown reason, the air cooling config was 4 degrees Celsius cooler than the AIO and air intake counterparts. I have no explanation, but likely it was just optimal for the specific GPU. As compared with the NR200P and Lianli A4H2, those are just 2 degrees Celsius hotter than the Meshroom. The PC cooler cases are 6 degrees Celsius worse on average as well. The hotspot temp is pretty much the same story with the temps ranging from 76.91 degrees Celsius to 83.55 degrees Celsius depending on configuration. The same goes for the GPU fan speed, and it goes to show that it doesn't need to work hard to maintain those temperatures. The same goes with the A4H2 and NR200P. While PC cooler, well, I already told its story previously. Overall, the temps in ITX are the best ones out there, especially in AIO configuration and sometimes in exhaust configuration as well. As for the CPU temps in Micro ATX while running Cinebench R23 for 30 minutes, the air cooler simply maxed out at 90 degrees Celsius, while the AIO config averaged at 82.11 degrees Celsius, which makes it 3 degrees Celsius cooler than the ITX config. The improvement is likely from the fans blowing air directly to the back of the motherboard. As for the CPU temps while benchmarking FF15 for 30 minutes, the CPU temps averaged at 64.15 degrees Celsius in AIO config and 74.76 degrees Celsius in air-cooled config. Both are significantly worse than in ITX config, but acceptable. The likely reason is that it's more difficult for the config to handle the heat generated by the GPU in this scenario, which is beside the radiator. The GPU temps average at around 70 degrees Celsius in both air and liquid cooled configurations, which is just slightly hotter than the ITX configuration. As for the hotspot temps, it averaged at around 83 degrees Celsius, which is again just slightly hotter than the ITX configuration. And of course, it applies to the fan speed as well. Overall, slightly worse temps than the ITX config, but acceptable. Also note that this is not an apples to apples comparison, as I use different motherboard and different configuration layout. It just shows how it can relatively perform. As for the CPU temps in ATX config while running Cinebench R23 for 30 minutes, for some reason, the liquid cooler performed 15 degrees Celsius worse than the air cooler. So the reason behind this is that there is not enough contact between the cooler and the CPU. This can be evidenced when I took out the cooler from the CPU and the thermal paste is not spread out correctly. The likely reason is that the LT520 standoff for the LGA 115X is too tall. I used the LGA 1700 standoff and I managed to improve the temps by 26 degrees Celsius on average. The thermal paste spread is more consistent now. Compared to the NATX V2, the Meshroom was 6 degrees Celsius cooler. As for the CPU temps while benchmarking FF15 for 30 minutes, the CPU temps averaged at 67.39 degrees Celsius in air cooling mode, while 58.01 degrees Celsius in AIO in proper contact. In its improper contact, it is at 73.37 degrees Celsius, which was was surprisingly acceptable and yet could have improved a lot. As compared to the NATX, the Meshroom was 13 degrees Celsius cooler. As for the GPU, the 3060 averaged at 70 degrees Celsius while the 3070 averaged at 73 degrees Celsius. As compared to the ITX config, the 3060 is pretty much aligned, but the 3070 performed 3 degrees Celsius worse than the NATX and ITX configurations. The hotspot temps are at 82 degrees Celsius for the 3060 and 84 degrees Celsius for the 3070. The GPU fans average at 76.57% for the 3070 while 79% for the 3060. Again, it seems that the 3070 in this position is thermally worse, although overall acceptable. I also tried installing an ATX PSU and it can really fit, but be sure to read the manual on where it would be compatible. I also tried a bunch of 90 degree and right angle adapters, and pretty much the right angle adapters are unusable since they will bulge out of the case. As for the 90 degree adapters facing towards the GPU side panel, this will not work as well as the cables will also need headroom and so they didn't fit. But if you will use a 90 degree adapter facing the motherboard side, it could work as shown. The height is just right even against the PSU. However, it can be a case-to-case basis and I would just suggest buying the feet instead or purposely built cables. I also tried an HDMI extender adapter which I used throughout the build and worked well. As for manual edit suggestion, for their basic user guide for ATX/mATX motherboard with front GPU, in step 3 they will tell you to remove the middle USB port. However, I suggest having a better guide on this. If they already have, then they need to reference it in this manual as it wasn't that straightforward. In step 7 position 1, the number of standoffs is inconsistent with the drawing. This should be remediated to avoid confusion. I also don't suggest immediately screwing on the PSU side to avoid conflicts in the latter part of the build. In 8-1 and 8-2, you can see the instructions for the GPU installation. However, on 8-3, it will tell you to connect the PCIe cable to the GPU prior to installing it to the chassis. But looking back at 8-1, you can see that the riser is already attached to the case, so isn't 8-3 too late at this point? Anyway, as for the things that I don't like in this case, first is the right angle display cable requirement, which is their biggest compromise to have the best compatibility. It is a hassle, and that's my reason why I didn't choose the Meshroom S as my editing rig. To be clear, you can use straight connectors, but you have to buy its feet, and of course, that's extra $30. Alternatively, I could spend a terrible amount of money and buy a 3D printer to print my own feet. Next is the official risers that I bought separately. Those are a real pain. It's not pre-folded, and there's not even a guide on the riser on how to fold it properly. I mean, I bought a first-party riser, not from some seller. It is branded as SSUPD riser, and so I expect something more rather than just a riser that I have to figure out how to fold correctly. The best would have been pre-folded, but I understand that some risers may have more than one possible use case. Also at the riser again, since the first-party risers had no allowance, it was actually scary as I might break them. Notice how the risers have been really stretched. I think they should sell the right angle male risers to prevent this from happening. I also firmly believe that this is the reason for signal degradation to Gen 3. As for the things that I like, well, the thermal performance was really the best one that I've tested. It has very good compatibility for a sub 15 liter case. Meshroom has better compatibility than my NR200P, which is 3 liters bigger. Although I complained a lot with the manual, it is actually very comprehensive and something that other brands should follow. To add, I already made 3 configurations in this build. One basic ITX build with rear GPU, one basic ATX build with front GPU, and one ATX build with rear GPU that can be found in their riser guide. There are other configurations that they documented, such as the ITX motherboard with SFF GPU, which will give you more space for HDD and or SSD, and 5 more configurations from their advanced user guide. Overall, I really like this case from a flexibility and performance standpoint, but I really can't recommend this for anyone because of the price. Typically, you'd spend around $200 for this case, which is roughly $100 more expensive than the NR200P and other SFF ITX cases. $100 is a lot though. For example, if you're eyeing on RX 6600, then you can pay that $100 difference to get the RX 7600 or RTX 4060 instead, which would give you 30% more FPS. For me, it also doesn't look stunning, and so it's not like the Denshum, which I'd recommend for aesthetics alone. But take note that this case is performance first. As for looks, maybe if you like the holes. As a likely male who is watching this video, maybe you do like holes. But I would definitely recommend this for higher end ITX builds, say GPU of RTX 4070 and above with i7 or R7 CPUs, as I think this case can handle such workload. I'd also recommend this for those who already have an existing ATX or micro ATX system that would like downsize to a smaller footprint, regardless of its spec. At that point, $200 upgrade would not seem much. As for the recommended config, you just need to follow the ones they provided in their user manuals. Those builds make sense from a performance standpoint for a balance of both GPU and CPU thermals. I'm also planning to release 2 more videos for this, so do wait for that. Anyway, that's a very long video for now, so that's it. This took way longer in terms of testing and production than expected, so I hope you like it. Do still leave a comment doon what you think of this video. Thanks for watching. Do like or dislike and subscribe for more unboxing, SFF build, and benchmarks. Bye!